Hi, everyone. Just wanted to take a minute to talk a little bit about dilations. So, dilations are a type of transformation. You've probably heard about them at some point. They are different from the other three types of transformations in terms of translations, rotations, and reflections. The main difference between the other ones and a dilation is that in the other three, they are considered congruent transformations because they don't change the size of the shape is preserved and they would be congruent shapes. A dilation, you will have similar shapes. So the size will change, but they will still be in the same proportion. All right. So, for example, when we're looking at dilations, we have here triangle OPQ is similar to triangle RST. That's another kind of way of saying it's a dilated triangle, if you will. Find the measure of side TR. Figures are not drawn to scale. Okay. So essentially what we're saying is when we're going from this shape to this shape, we know they have to be in the same proportion. All right. We know they have to be in the same proportion. So that means if 3 becomes 15, right? Well, that means I'm multiplying times 5. That means I have to multiply this times 5. Now 5.8 times 5. That would be 0, 4, 29. Okay, so it would be, TR would be 29. Okay, so that's all a dilation is, right? We're going by the same amount each time. You can set up the proportion, you can find the scale factor. In this case, the scale factor was 5, and multiply one of the sides times it, okay? So any of those would work, all right? Whatever your choice would like to be. Let's do another one for good measure. So again, I am trying to find OP, or a side. And again, it tells me these are similar. So if I can find the scale factor, I can figure out what to multiply them by. So 2 is times 4 to become 8 times 4. So that'd be 3.4 times 4, 6, 1, 13.6. Okay. I'm just multiplying by 4. I'm multiplying by my scale factor of k. Now, one thing to consider is there's two types of dilations that we really focus on. We talk about enlargements. That's when your scale factor is bigger than 1. And reductions, which will be when your scale factors are smaller than 1. Now, typically when we're looking at these, I mean, I'm calling these kind of like an intro to, as part of dilations, but realistically what's happening with a dilation is you're doing it on a coordinate grid. Okay, so if you're doing it on a coordinate grid, essentially what you have to do is you have to dilate like a point. And when you're doing that, you have a center of dilation. So the center of dilation is essentially the point that you're going to be dilating about. The most common and typical one is going to be the origin. Okay, so basically what it's saying is if I have a shape like this, and I'm, enlarging it by a factor of 4, I'm going to essentially just multiply every single point by 4, and I would get, something like this. All right, so it's kind of like scaled up. Right, you get what I'm saying? It's gotten scaled up. And this is, if you continued it down and you made it smaller, it would kind of collapse into that center. It is possible to do dilations about things that are not the origin, but that's a bit of a pain. So we're really not. Typically, if you do it, it'll be on like a line, and you'll kind of basically just do like scales of the slope. But for the purposes of this, we are centering about the origin. So we are scaling by a factor of 1/4. So this is a reduction. It is getting smaller. Okay, so essentially all I'm going to do is I'm going to multiply each of these by a 4th. Times 1/4 times 1/4. And if I had a whole shape, I would multiply every single coordinate by 1/4. Okay, so when I multiply that by 1/4, it would become -2, -2. Nothing crazy. Okay, see, you just multiply everything by your scale factor. So this one here would be this would be an enlargement. You're multiplying by a number bigger than 1. right? So it's going to get bigger. So if I multiply both coordinates by 3, the 0 doesn't change. So that's essentially what we're saying here is I already have a point at my center of my origin, it's not at the origin over 5 of 0, right? But it's not going to go off of it in a vertical direction. Okay. So that would be 15, and that would be 3. Whoop, no, it would not be 3. 3 times 0 is 0, not 3. So that's really what we need to know about in terms of dilations. You could confirm that things are dilations by finding the distances and then finding a scale factor. All those are totally reasonable and appropriate. But ultimately, when you're dealing with a dilation, all it is you are multiplying the coordinates by a scale factor if you are dilating about the origin. All right, let me know if you have any questions and have a great day.